number 17 through 25 for our review number 2. We are given in number 17 a division problem, 18x to the 9th minus 12x to the 6th plus 9x to the 4th, and it's all being divided by negative 3x to the 4th. So our first step on these division problems is everything in the top here is being divided by our negative 3x to the 4th. So the first thing we want to do is just go ahead and split it up. So we'll have 18x to the 9th divided by our negative 3x to the 4th minus 12x to the 6th divided by negative 3x to the 4th plus 9x to the 4th divided by negative 3x to the 4th. And once we have it split up, we can just go term by term to simplify. So if we look at our first one, we have 18 divided by negative 3 to give us a negative 6, and then take a look at our x's, x to the 9th divided by x to the 4th. When I divide like bases, I subtract the exponents, so 9 minus 4 would leave me with an x to the 5th. Negative 12x to the 6th divided by negative 3x to the 4th. First, a negative divided by a negative, that's going to make a positive, and 12 divided by 3 is 4. X to the 6th divided by x to the 4th would actually be x squared. A 9 divided by negative 3 would be minus 3. And x to the 4th divided by x to the 4th cancels to a 1, but we don't need to bring that down because negative 3 times 1 would just be negative 3. So now we have our final answer. Every term in our numerator has been divided by our denominator. Number 18, we're also given a division problem, 54x to the 4th minus 12x cubed plus 6x squared divided by negative 6x squared. So again, every term in the numerator is being divided by our denominator of negative 6x squared. So we can go ahead and split up each term. So we'll have 54x to the 4th divided by a negative 6x squared minus 12x cubed divided by negative 6x squared plus 6x squared divided by our negative 6x squared. So a question I get asked a lot that I didn't address in number 17 is, where are these signs coming from? So this minus sign is coming from the minus sign that was in front of our 12x cubed. And then, sorry, trying to change colors here. Well, we're just not going to change colors this time. And this plus sign is from this plus sign here in front of the 6x squared. And then the negatives in our denominator are just coming from the original denominator of negative 6x squared. So we just want to carry over all those signs so we make sure we end up with the final result that's correct. So moving on, now we are actually ready to start dividing. So if you just handle the numbers, 54 divided by negative 6, that is negative 9. And x to the 4th divided by x squared, we'd subtract those exponents and get x squared. We have a negative 12 divided by a negative 6, which would give us a plus 2. X cubed divided by x squared would be x to the 1st, which we can write as just x. And then 6 divided by negative 6 is a negative 1, and the x squareds cancel out. So on all of these division problems, you guys aren't going to have anything more in this class than dividing by a monomial. So we just split it up like I have here in the blue and then simplify each term. Now that we're working on 19 through 25, we are simplifying. So if you look at 19, you're told that we have 8 to the 4/3. And if you remember, a fractional exponent converts to a radical expression. So we could actually convert this into a radical so we can simplify it. So over here off to the side, I'm going to give you that format in case you forgot. If I have some base that's raised to a fractional exponent, I can convert that to a radical. The base will go inside my radical. The m is my exponent and the n is my index. So the n goes in this little wedge right here, and then all of it gets raised to the exponent of m. So we can follow the same procedure for 19. So the 8, that's my base, it's going to go inside and become my radicand. 4 is my exponent, so it's out here. And the 3 is my index. So that means I'm actually taking a cube root. So whenever you think about a cube root, you're asking yourself what multiplied 3 times will give me 8. So if you have trouble figuring that out, you can do a factor tree. So I'll do a little factor tree off to the side here. 8 is really 2 times 4. Those are 2 factors I know of 8. And then 2 is not going to break down further other than 1 and 2. But 4 is 2 times 2. So if you look at how many 2's I have here, 1, 2, 3, and that's exactly what I was looking for if you go back to your index. So the cube root of 8 is 2, but this guy is still being raised to my 4th power. So 2 to the 4th is just 2 times 2 times 2 times 2, and if you multiply that out, you should get 16. Looking at number 20, it's the same thing. We can't just in our heads, most of us, think what 27 raised to the 2/3 power is. So we'll use this conversion over here and convert it to a radical notation. So let me get my radicals set up, my parentheses. So inside, I'm going to put my base, which is 27. My index is my denominator of the fraction, so I'm taking a cube root again, and my exponent is the numerator. So I'll take my cube root, and then whatever I get, I'm going to have to square. So cube root of 27. So if you're not sure what that is, again, little factor tree off to the side. We have 27. Identify 2 factors of 27. I know I have 3 and 9, and 9 breaks down further into 3 times 3. So again, we have found 3 factors that are the same. So the cube root of 27 is just going to be 3, and now we have to do 3 squared, which equals 9. So in order to do these problems, you have to know this radical notation right here. You have to know how to convert back and forth. So looking at 21, it's already given to you as a radical. So we don't see an index right here. So when you don't see a number there in your index, it implies a square root. So we know we're taking the square root of 81 m to the 6th power. So whenever you're taking a square root, you're asking yourself what number times itself, so the numbers have to be the same, are going to give you 81. So if you think about it, 9 times 9 is going to be 81. So we know that the 81 will come out of the radical as a 9, but now we have to figure out the m to the 6th. So what times itself gives you m to the 6th? So you got to know those exponent rules. And m to the 6th can actually be split apart as m cubed times m cubed. And when I multiply like bases, those exponents should add. And 3 plus 3 would get me back to that exponent of 6. So the square root of 81m to the 6 is 9m cubed. So I'll just put that all in one color. They're just all multiplying here, 9m cubed. So now we're going to take a look at 22 through 25. We're still simplifying, but now I'm looking at some square roots where they're maybe not perfect squares inside the radical. So if you were to try to square root 240, you wouldn't be able to do it. It's going to come out to a decimal. But that doesn't mean that we can't simplify it. So by simplifying, we're trying to find a factor of 240 that's a perfect square. So what I'm going to do across the bottom of my screen is write out my perfect squares. And if you have trouble figuring out what, is a perfect square, we all know how to count. So we could all just do 1, 2, 3, 4, and just keep going. And I'm going to go out just a little ways. I'll go out to 13. And then just square each of the numbers. So 1 squared would just be 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. You can keep going, but I do notice that none of my numbers really go too high, so this list should do us some good. So 240 is going to fall at the end of my list, and I would start dividing it by all of the numbers that fall below. So we would start with, for instance, 169. So you're going to go down this list a ways, and 240 actually doesn't divide by any number in our perfect squares list until we get to 16. So that means I'm going to use 16 to simplify. And so 240 divided by 16 is 15. So 240 will break down as the square root of 16 times 15. So we have 16 times 15. So 16 is a perfect square. So I could actually square root 16 and it's going to come out, but the 15 has to stay where it's at. I cannot square root 15, so it is going to stay inside its house. So when I square root 16, it's not going to be 16 anymore. It's going to come out as a 4. But I'm still going to have square root of 15, and the 4 and square root of 15 just get multiplied together. And the way we would say this is 4 square roots of 15. And now your radical is simplified. Taking a look at 23, we have the square root of 49y squared. And if you look down at your perfect squares list here in blue, I actually see 49 right there. So that means that 49 is a perfect square, and we could just go ahead and do that operation. So the square root of 49 is 7, and the square root of y squared, well, that would just be y times y. Therefore, the square root of y squared would just be y. So 24, if you try to square root 48, it's not going to work. So that's when we would go to our list and see if we can find any factors of 48 that are perfect squares. So let me find another color here for this one. So 48 falls right in between 36 and 49. So we would start dividing 48 by 36. You'll find that it doesn't work. Do 48 divided by 25, not going to work. But when we get to 16, 48 divided by 16 is 3. So that means 48 can be broken down as 16 times 3. So we'll break that down inside our radical. So it's going to be 16 times 3. And then again, the 16 is going to come out, Sorry, I was having trouble changing colors again. So we have the 16 right here, and it's going to come out. But if it comes out, it has to be square rooted. So the square root of 16 is 4. So 16 will come out as a 4. But the 3, I can't square root it, so it's going to stay inside the radical, inside our house. So we have 4 square roots of 3, and it is simplified. So our last one here is number 25. We have the square root of negative 175. And again, 175 is right here at the tail end of our list, right here. So you could start dividing it. And I'm just going to warn you, you're going to have to do some dividing before you actually find one. So we would divide by 169. Then we would see it wouldn't work, so we'd go to 144. It's not going to work. Try 121. And you're going to keep going until you find one that does work. So if we were to divide by every single number, we'd eventually get down to 25. So the square root of negative 175 could be broken down as negative 25 times 7. So we can break that down inside our square root. We will have the square root of negative 25 times 7. But that 25 right here, the negative 25 is going to come out. And what's even more important here, or not more important, but what we also need to remember is that it is negative. See this negative here from the get-go. If you see a negative inside a square root, you should automatically know, you should be thinking in your head, there is going to be an I. Okay, so there will be an I. It's going to be an imaginary number because the square root of a negative is not a real number. So as I bring out the square root of negative 25, it's not just going to come out as an I, 5, but it'll come out as an I, a 5I. And then you'll still have your square root of 7.